Hi, Sabil. My name is Farish Rizky Nakla bin Mohammed Saleh. So firstly, I will talk about the introduction. In the era of rapidly evolving information technology, the extraction of meaningful insight from vast dataset has become increasingly critical. One of the most tools utilized for this purpose is Weka, a comprehensive suite of machine learning algorithms developed by the University of Waikato. This study focused on analyzing an employee dataset sourced from the UCI machine learning repository. First, we aim to identify the most significant factors influencing employee performance and retention. Second one, we evaluate the effectiveness of different machine learning models in predicting this outcome. And finally, we intend to demonstrate the practical application of data mining in enhancing organization decision-making process. The research aimed to offer practical insight that might improve personnel management procedure and lower attrition rates by spotting trends and forecasting results. This section cover data mining and associated research topic in the realm of worker productivity, particularly at the educational levels. Higher educational levels equip employees with advanced skills and knowledge relevant to their field. Investing in the education of employees not only enhance individual performance but also drive overall organizational success and sustainability. Higher education levels are notably correlated with better performance, underscoring the significance of educational attainment in raising worker productivity. The research conducted by this study on a dataset from UCI Machine Learning Repository emphasized how improving educational attainment may lead to significant organizational success. The finding revealed that higher education levels are positively correlated with higher educational commitment and improved employee performance due to better skill, knowledge, and dedication to organizational goals. By organizing the literature into subtopic, it becomes evident that higher education level lead to enhanced job performance and increased organizational commitment. Thank you.
In this study, we use data mining method. This methodology involves placing an employee dataset through several stages to arrive at insight. First of all, the dataset is cleaned in order to get it ready for analysis. The data then undergoes three processes, that include the classification, association, as well as attributes the selection. Classification entails the use of data structure like by-nets logistic regression, SGD, and weather 3 and 48 to classify the data. Based on the data structure, associations roles are determined to discover relation within the data set. Data mining includes descriptive and predictive technique for meaningful knowledge, which is unknown yearly from data. Albayrak and Yilmaz 2009. This method, such as infogain attribute EVA and correlation attribute EVA, are employed to select the appropriate factors. The outcomes from this process are then aggregated and displayed to create the output.
Today I would like to share with you about analysis and result. The first is data processing phase. This phase involves preparation of the data ready for analysis and a preliminary examination of the data set. The attributes include information about the employee's educational qualifications, the year they joined, the company, the city where they are based, their salary, tire, age, gender, bench time, which means whether the employee has been put on temporary leave with no work project. and years of experience in the current line of work. The target variable is whether the identified employee left or did not leave the company. The attributes are categorized into nominal as their values are qualitative, not quantitative in form. For instance, the educational qualification are further classified into bachelor, masters and PhD. Joining years is split into intervals and city is broken down to Bangalore, Pune and New Delhi. Likewise, the salary tiers factors are gender being bench and experience are categorical variable in a nominal category. So number 2 is feature selection. One of the necessary phase of the data analysis is feature selection because it determines the attributes that affect the target variable. Two methods are employed for feature selection. In this paper, we introduce two, which is information gain ranking filter and correlation ranking filter. These two are basically supervised algorithm and both consider the class variable, which in this case is whether an employee is going to leave the organization or not. In the case of the feature selection, the function result indicate that the payment tier, gender, city, joining year, education, average bench, age and experience current domain are the most relevant feature. This implies that these factors out to have a major correlation with the turnover of the employees. Number 3 is specifying the select algorithm, which is classification. In this part of the document, the choice of correct classification models to predict the probability of an employee's turnover is explained. The accuracy of the algorithm are compared, where accuracy is defined as the number of actual correct classification by the algorithm divided by the number for instance. Thus, it is again BiasNet and logistic which have displayed the highest accuracy with a slight difference where logistic outperform BiasNet. The stochastic gradient descent SGD also ran high tau. Its accuracy is somewhat lower than the above discussed algorithm. Point number 4 is classification algorithm selection. The reason for selecting specific classification algorithm will be discussed. This could contain issues relating to the number of features in the discrete data, type of data that is nominal, as well as the size of the dataset. For each of the selected algorithm, the detailed information about their theoretical foundations, principle of operation, and advantages as well as the weaknesses will be provided by BiasNet, logistic, and the stochastic gradient descent SGD, among others, will be explained. The specific values that will have been used for each of the algorithm will be included and explained. For instance, the type of the core that should be used for a logistic classifier, or the values of the regularization parameters or the learning rate that should be used for the stochastic gradient descent SGD classifier and the loss function that goes with it. This will define any data pre-processing that will be done to the data before it was fed into the clouds of classification algorithm. This could include normalization or standardization, or how the missing values could be dealt with. In addition to the measure of accuracy, other measures that will have been touched when evaluating the classification algorithm include precision recall F1 score, as well as the confusion matrix. All the algorithms will be compared based on the chosen evaluation matrix that will have been defined earlier. The section will explain why some of the algorithm was better off than the other and what such impact will mean to the analysis. The section would close by identifying the classification algorithm to be used in the analysis, since this will have been evaluated and complex. But not least is number 5, which is association rules result. A priori is applied to generate association rules in the case if then rules that assist in revealing the relationship between attributes in the dataset. Rules are then sorted and ordered by support, which is an effective measure of rules importance, confidence, which measure the strength of relationship, lift and leverage. Among all the Discover Association rules, several interesting trends can be highlighted. For instance, payment for the employees in Bangalore are categorized under payment hire, and if an employee belongs to Table 4, he is most probably a bachelor's degree holder. Another interesting observation in that on not being benched and on his or her policy of not to leave the company, they contain guidelines which one can use to develop the tactics and policies within the domain of HR.
The decision to analyze how factor-thematic gender, education, joining year, and city play a role in wage assignment or no-based assignment of an employee. The first decision point is on the payment type 5, which further splits the three companies based on its value. Regarding payment type, which is R lower than 0.5, the three split by joining year and education, which means that these variables, as well as city and gender, are influenced by benching status. The three reveals that an organization of such attribute result in different probabilities of an employee being benched, and the determiner notes provide a summary of this outcome. As shown in the presented in Figure 3, we find how the education level of the employee is related to the joining years they have in the organization. This reveals our career progression of the employees who obtain different level of education. For green is PhD, red is master, blue is degree, and joining the company between 2012 and 2018. The data points have been color depending on the education of the candidate, so one can have a visual appreciation on how hiring trends have been over this year. This figure 4 has shown the trend of the number of employees leaving the company based on their gender, including green for those with PhD, red for those with master degree, and blue for degree. It also reveals the fact that there are separate clusters for those stay and those left for both male and female employees, which may indicate the possibilities of gender-based pattern of turnover. The visualization makes it easier to spot large disparities in elevation rates of male and female employees sorted by their education level. Here in Figure 5, the x-axis is the distribution of employees based on the city they work in, and the y-axis is indicating if an employee have been benched or not. And lastly, the classification is done based on the education level of the employee. It reveals a bench status of each employee based in Bangalore, Pune, and New Delhi, which provide a perspective on pitching patterns. The visualization revealed that the pitching is not the same throughout the cities. However, both pitching and non-pitching personnel are distinguished with a little depression throughout every city, potentially suggesting regional difference in workplace deployment. That's all from me.
In conclusion, our study demonstrates the effectiveness of data mining techniques in analyzing and predicting employee turnover. Logistic regression stood out as the most effective model. Through this process, we identified key factors influencing employee performance and retention. This underscores the importance of leveraging advanced data analytics for informed decision-making in human resource management. Moving forward, there are several areas we aim to focus on to enhance our predictive models. First, we plan to improve accuracy by integrating more sophisticated data pre-processing techniques and exploring additional machine learning models. Expanding our dataset to include employee personality, traits, and digital competencies will provide deeper insight. Furthermore, we intend to analyze the impact of different employment modes on employee well-being to gain a comprehensive understanding of factors affecting performance and retention. Based on our finding, we have several recommendations. First, we suggest adopting logistic regression as the primary model for future predictive analysis due to its high accuracy. Second, expanding data collection to include additional attributes like employee personality traits and digital skills will enhance our predictive capabilities. Continuous monitoring and regular updates of our models with new data are crucial to maintaining predictive accuracy. Finally, utilizing the insight from our analysis to design a targeted employee development program focusing on key factors like educational qualification and job satisfaction will help improve overall employee retention and performance. Okay, that's all from us. Thank you.